Hi, good evening, class. So, today we are going to start with a new topic of discussion, which is SQL, or also known as structured query language. So, I'm going to refer to the two PDFs. One is basic SQL and another is advanced SQL for most of the course elements. And we're going to go with the flow as it's present in the PDF because that's quite well structured. All right. So we'll keep the format of the class similar. We'll go over each topic, and at any point in time, if you have any questions, keep that part at the end of the topic. You can ask me those questions, or when you on the days that we don't have classes, you can practice and then get back to me in case you have any doubts or questions. All right. We'll shortly get to the interface on which we are going to be learning SQL. But prior to getting to SQL, we need to have a bit of a background about what is SQL and what exactly is all of this concept. So we're going to talk about few conceptual elements, which is going to help you understand SQL. All right. So the first thing that we need to cover is what is a database. So a database is a organized collection of data, a structured organization of data. Now, the data in a database is usually stored in tables, which consists of rows and columns. So think of your basic Excel. How do you see your data? It's organized in the forms of rows and columns. So each of your observation in the data is an individual row, and each column is a separate field. Okay.
Hi, Shravan. Can you please speak a bit louder?
Uh, I am speaking
This
the
is winning.
longest that I can actually. Hold on. I can do something with my mic. Actually, my mic is also set. So do you mind increasing your volume a bit and seeing if that helps?
Yeah, okay.
Great, sorry. Yeah. Okay. Um, all right. So we were talking about a database. So a database is a way of organizing data. Think of it like a nice structure in which all of your data sets are going to sit together. We're going to get to this four operations in a bit. But for now, just understanding a database is enough. So a database is nothing but an organized collection of data, which is structured to facilitate easy access and management. Okay. We'll talk about CRUD operations in a bit. So CRUD operations is essentially the basic operations that you do in a database. CRUD stands for create, read, update, and delete. And there are specific codes or functions present in SQL which help you do each of these operations. We'll talk about this once we introduce you to different families of commands in SQL. So then understanding these CRUD operations would be much more easier. All right. So now we understand the concept of database. A database is what? It's a collection of data sets. Okay. Now, in order for you to manage that database, the software or the system which is available, that is called a DBMS, or a database management system. So a database management system is a software tool, call it a software tool, call it an interface, call it a GUI, which is going to help you interact with the databases and all the elements sitting in a database. Now, mind you, when we get into SQL, you'll see that you just don't have tables. You're going to have some other kinds of elements also in a database. For example, we'll see views, we'll see stored procedures. I think we'll also see functions. So a DBMS, we're going to call database management system as DBMS from now on, is a software tool which is going to help you interact with that database. So think of your Jupyter, when you're working on Python, your Jupyter notebook is the interface on which you're doing all of your coding. So in this case, in SQL, it is called a DBMS. Now there are various kinds of DBMSs available in the market. Broadly, there are two categories of DBMS. One is a graphical interface. A graphical interface is a more user-friendly kind of interface that allows you to interact with the database. So anything which has visual tools in it, visual tools in the sense that you will be able to see your database, you will be able to see the tables inside it, and you would be able to see some elements of those tables. For example, what columns are there in that table, how big is that table, when was it created, those kind of things. So this is called a graphical user interface of a DBMS, and this is usually more easier to understand and comprehend, specifically for first time users, because you can actually see the visualization is there for you. Examples for that is Microsoft Access, MySQL Workbench, PHP MyAdmin, and also we are going to be using Google Big Studio in Google, which is also a graphical interface. All right. The other is a textual language interface. So think of like a command prompt kind of a box where all you will do is simply code, and it is going to give you snippets of the data. If you guys have worked with command prompt before, you know that you can't really see the elements which are sitting in the form of, acha, this is your database, and the structure of it, the tables inside it, those you cannot see in a command prompt. What you can see is when you type a code, it is going to throw some output. For example, if you want to see how many rows the data has, how many columns the data is. So that's a textual language interface. So it works using textual commands, typically through a query language like SQL. So MySQL has both. It has the workbench as well as it has a command prompt kind of a interface also. People use both. Some people are more comfortable using a textual language interface. We will not be using this at a textual language interface at this point, because once you understand the structure of how a database works and how does SQL work in general inside that, then you can start using maybe a command prompt, a MySQL prompt to work through it. Okay. Now, features of a DBMS. Features of a DBMS is, what does it help with? What does this interface help us do? So it helps us with data abstraction. That means it will hide the complexity of the data from the users. So essentially, a database is storing the data set, right? So it is going to be storing it in a particular way. It's going to put it in, it's going to do some encryption, it's going to save it in a certain format. Now, if that is shown to people in general, it can get very difficult for them to understand that data. So a DBMS helps to hide that complexity of the data and show you the data in the form of simple rows and columns in the form of a tabular format. Data security, of course, it's a software tool which is going to give you certain levels of authorizations. So you can set authorizations for your databases as well as elements sitting inside the database, so that only certain users can access certain elements of the database. For example, let's say there are 5 different databases, and let's say only one group of users needs access to all 5 of them. So it's going to be a need-based privilege which is going to be set up. There's a certain set of commands called DCL commands, which help you set privileges in terms of your database elements. Data integrity means maintain accuracy and consistency of data over its life cycle. This element and concurrency control. So these two are very, very important per se, that let's say there are multiple people who are working on the database at a point in time. Okay, they're parallelly working. And let's say I am making some changes in it and you are already accessing that data. So what can happen is, if those changes, so how is it getting controlled that the changes that I'm making, where will you be able to see them real time, or will it or let's say you are doing some coding on top of that data set and I'm changing the data in the backend. Okay. Now, what can happen is, if the concurrency or the parallel activities on that database are not controlled in a proper manner, what can happen is you can get an error when you are running your codes on the data. Let's say I have deleted the data on my end, okay, and you are still working on the data set. So then you will get an error that the data doesn't exist. But for that session, there are going to be certain checks and controls in place, which ensures that your code doesn't run into an error. We'll talk about data integrity and concurrency in greater detail in the advanced topics. Just understand that it has certain checks in place, which helps people to parallelly work on that database together. Backup and recovery, because it is a database and data is one of the most precious asset for a particular organization. So of course, DBMS needs to have a good mechanism, a very robust mechanism to back up the data and restore it in case of failure. So let's say someone has accidentally deleted some part of the data sets. So there should be ways to restore it back. Okay. We'll talk about these elements in greater detail in terms of the functionality of DBMS as we move forward. Today's session is just about introducing you to the different things that a DBMS helps you do. Okay. Now, where does SQL come in all of that? SQL, or structured query language, is the programming language which is used to interact, manage and manipulate relational databases or interact with those databases. Now, in your Python is that language that you're using to interact with data sets, do different descriptive analytics on top of that, create models, get output. So in a similar fashion, SQL is the programming language which is used to work with relational databases. Okay. Now, I'll get to the concept of relational databases in a second. Let me just finish this part. SQL is widely, it's one of the oldest database RDBMS programming language, which is very easy to understand, very intuitive, and it is widely used across organizations. I mean, in terms of the other tools that you might learn, it might so happen that you might use Python, you might use R, you might use maybe MATLAB, Scala, SAS, anything to do your modeling exercises. But when it comes to database management, database manipulation, SQL is used across all organizations. It's one of the most common tools which is used in the analytics industry. Okay. Now, what is a relational database management system? So there are two kinds of DBMS. First we understand the concept of a DBMS. A DBMS is a software tool that helps you to interact with a database. Now there are two kinds of DBMS. One is called a relational database management system, or RDBMS, and another is NRDBMS. NRDBMS, essentially, if you've worked with maybe Cassandra or MongoDB, those work with NRDBMS. Now, what's the difference? In very, very simplistic term, whenever you're working with a tabular form of data, okay, which is organized in the forms of rows and columns, it is always going to be in a relational database management system. Okay, so your RDBMS always stores data sets in tabular formats. And the second thing which is very important is all the elements of your database are going to be related to each other. There is going to be a certain relationship which exists between all tables, all views, stored procedures in your database, which is going to help you retrieve that data or manipulate that data easily. These two things, the data being organized in tables, and second, all the tables being linked to each other in some way or another through different keys, those two things are not there in an NRDBMS. If I can just give you a very small example, in Python, you do something called in your data dictionary. When you have a dictionary in Python, you have a key value pair. So MongoDB stores the data exactly in that format. There's a key value relation system which is present in MongoDB, and that's essentially how NRDBMS work. But NRDBMS is not our topic of concern today. Our topic of concern is RDBMS, and SQL primarily, not primarily, it only works with RDBMS. Is that clear? Are the three concepts here clear? First is database. So database is that whole ecosystem where all of your elements are going to be saved, mainly tables. I think for the first 3-4 classes, we are going to only talk about tables, and then we'll get into views and stored procedures in later sections. Then the software that we use to manipulate databases is called RDBMS. RDBMS is Relational Database Management System. Relational Database Management System means that your data in your database is going to be stored in the form of tables, rows and columns. And second, all of those entities sitting in your database are going to be related to each other through some keys. Okay. And what is SQL? SQL is the programming language that you use to work in your RDBMS or in your or in that software. Okay. Now, SQL is a universal language because it's a language. You can code it anywhere that is compatible with SQL. Now, I'm not going to get into history and evolution. You can read it on your own. Key characteristics of SQL. Okay. So SQL is a structured language. It is well defined with syntax and a set of rules. The structure ensures that SQL commands are precise and consistent. This is going to be understanding the well-defined syntax and set of rules. How do you code in SQL is going to be the primary objective of these sessions. Second, it organizes data into tables, which consists of rows and columns. So this is essentially your RDBMS. This is the definition of RDBMS. Keywords. SQL specifically uses keywords to perform operations on data. Not just these, so I'm going to ignore these keywords, but SQL is very keyword specific. So for every functionality, you have a different keyword, but I guess that applies for most coding languages. So each keyword serves a distinct purpose and follows a particular syntax. That also applies for all programming languages. SQL is designed to query databases, allowing users to ask questions and retrieve specific information. So SQL is a query language. You essentially want to set a query or specifically you have a certain requirement in mind per se that, okay, from the entire data set or the collection of data sets, I want this element in this format. So you create a query using SQL and then you give it to your database and then you get an output from the tables. This is essentially the whole purpose of SQL. Now, what are the fundamental concepts? First entity in your DBMS is your database, because we spoke about what a database is. It's a collection of data stored electronically in your computer system. How does it store it? In the form of table, tabular entries. So table entries consists of rows and columns. Each table represents a specific entity such as customer, order, products, etc. Okay. Rows are records. A row represents a single implicitly structured data item in a table. Exactly how it happens in Excel. A particular row is an observation. That's what it is trying to tell you. A column, also known as a field or an attribute. So it is talking about a particular a column is going to be a particular field in your data set. Okay. We understand this concept well. It's a uniform way of how tables work. All right. Again, they're talking about CRUD operations. This I will talk about after I introduce you to the families of commands in SQL. Okay. Any questions up to this point? All right. So if there are no questions, let me introduce you to the tool on which we are going to be working on. Now, Please bear in mind that most of the codes that we have here are compatible with MySQL. Now, MySQL is one tool which is used very commonly to query. So it's to code using SQL. But we are not going to be working with MySQL. We are going to be working with a better tool, which is Google BigQuery. Now, the reason we are not working with MySQL is because the setup, the installation can have some issues, and it's going to take up a lot of space on your system. And essentially, it takes up a lot of time to do the setup. Whereas when we are going to be working with BigQuery, it is you don't really need to do any installation. All you have to do is create an account, authenticate it, and you're good to go. You can start working right away. So it's a better way of working, and also you get an experience of working with Google Cloud Platform. Google Cloud Platform has a lot of tools which are used for different kind of activities, and BigQuery is essentially used to work with SQL. All right, so there is going to be one Word document here, and also I think you should be given a PDF called BigQuery. I'm not going to cover the different functionalities of BigQuery in greater detail because that's not something which is important to understand SQL. I'm going to cover only those things which you need to understand to work with SQL. So there's a Word document which says Innovit BigQuery. Go through it and install BigQuery. Get your BigQuery account up and running. BigQuery is a fully managed serverless data warehouse offered by Google Cloud that allows for fast SQL queries. So think of it like a interface that you're going to use to code using SQL. That's it. That's what you need to understand for these sessions. But for your understanding, if you're interested in BigQuery, they've given you a very nice tutorial which talks about all the things that you can do in BigQuery. Okay. Where's this Excel? Okay. So first, you'll have to go to Google Cloud Platform and sign up for a new account. So essentially, if you have a Google account, you can use that account only. All you have to do is you will have to go to this. I've already set it up, so I cannot show you the steps. It's very simple. You just have to go here. Then click on get started for free. And then it is going to ask you your email ID. I'm using a different work related email ID. Just do next, 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 set up the account. And then the other thing that you need to do is, so the other thing that you need to do is set up a payment. So understand this, that Google Cloud gives you two ways. One is a sandbox account. So Google Cloud Platform Sandbox, it's going to give you where you can do some bit of coding, but there are certain limitations when you set up a account without payment information. So it's not going to let you run your DML commands, and there are going to be a lot of restrictions. So follow the instructions to create a new account and provide billing information. Now, bear in mind, you just have to provide certain billing information. Any credit card or UPI account, anything will work. And you will get $300 of free credits. For our activities, these free credits will also not get used. So it's essentially a free service, and you can only use it for the first 90 days without paying up Google. Okay. So set up this account and then provide billing information so that you are able to run all kinds of queries. Okay. Now, once you do that, your interface is going to look like this. Okay. I'll go back to my console. Right. So this is how the console is going to look like. Then you need to do one thing. Go to APIs or services from here or from navigation menu. In APIs and services, go to library and type out BigQuery over here. Press enter. Go to BigQuery API and make sure that over here there will be a button called, I think it's going to be called enable. Yeah. So make sure that it is enabled over here. I have already enabled it for myself, so that's why it says API enable. When you set up your GCP console, it will have an enable button here. Click on that and enable this. Otherwise, your BigQuery Studio will not work. Okay. You need this Word document is pretty good for to. It has a step-by-step screenshot also, so you can use that. Enable that like this, and then there you have it. Okay. Now, once this is enabled, your first project will get created automatically. You won't have to do anything. Go to these 3 lines over here. There will be a tab for BigQuery. Go on that and go to the first one, BigQuery Studio. This is where you need to be. And this is how your page will look like. Okay, this is a different, so I have to use this one. Right. Okay, so once you're here, this is where we'll start coding and doing all of our work on SQL every day. So make sure that you are able to reach this page. Welcome to BigQuery Studio, blah, blah, blah. This is how it will look like. Okay. Now, very quickly, let me give you a walkthrough of the interface. So the first thing is it's going to create automatically a project for you with some ID, its own generated ID. Let it be like that. Don't worry about it. And that project will show up here on your Explorer tab. Okay. Now, everything that we do here is going to appear in these elements. Okay. Now, first things that you need to do is get your data sets inside BigQuery. So understand this, that your project is the outermost shell in BigQuery. Within that, we are going to create something called a data set. Now, a data set is the equivalent of a database. So whenever in your text, whenever you read that you have created this database, blah, 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 in BigQuery, it is called a data set, not a database. Okay, it's just a differentiation of how they call it. How do you create a data set in BigQuery? This is going to be a project name. There are going to be 3 buttons next to it. We will click on it, and the first option is create data set. I will click on that, and this kind of a dialog box will come up. All we have to do here is give it a name. Let's say, let me call it classwork. Now, location type, you can choose a region or you can allow it to be multi-region. Multi-region is better in terms of performance because then basically your servers, which it is going to hit in order to execute your queries, is going to be spread across multiple regions in US. So you're not going to have performance issues. After that, for the next elements, you don't have to do anything. You can ignore rest of the options and just say create data set. It says classwork created, go to dataset. Over here, you will be able to see a new tab getting created called classwork. Okay. Now click on that, click on this triangle next to classwork. Once you start having data, once you start importing tables into Tableau, into SQL, or you start creating tables from scratch, they are going to start getting reflected here. Okay. Now I will import 3 data sets within this data set. Okay. How do I import tables within this? Click on this small 3 button next to the data set which you're going to be using. I have another data set also over here where I have certain tables imported. But for showing you guys, I'm going to create a fresh one. So within classwork, click on this 3 button. Third option, create table. Click on that. It's going to open a dialog box like this. Now create table from empty table. So first I'm going to import a table from my system, okay, from my physical C drive. Click on this drop down and I'm going to say upload. I'm going to choose the third option, upload. Second option, second thing, select file, click on browse. So let's say in downloads, I have these files set up. So let's say I want to import employees file. So I'm going to click on employees, wherever you have these files sitting, open it up. File format automatically takes as CSV. The project is this project only. If you have multiple projects, you can change it from here, but we are going to work with a single project, so let it be that. From here, you can change the data set. So if you have multiple databases and you want to import this data in a specific database, mention that name here. Here you have to give a name to this table. So the name by which it is going to get imported within your BigQuery. So let me call it by the same name, employee. Then schema. So what is schema? Schema means how the data is organized within that particular table. So essentially, what kind of field names are there? What is the data type of those field names? What kind of information is sitting in them? That is called schema essentially for a table. So I'm going to click on auto detect for this one. I'm just going to click on auto detect. And then I don't have to do anything else. I will say create table. So this is doing a load job. And then it has created this table and saying, do you want to go to table? Say, okay. You can either go to table from here or here. So now you see under classwork, we have a table which is present, which is called employee. Click on that and that table will open up over here. So let me walk you through all of these. This is the schema. So schema is what are the field names? What are the different data types of each of those field names? Okay. If you want to see a quick preview of the table, click on preview. And this is your preview of the table. It says that there are 299 observations here and you can scroll through 50 of them. And that's what we need at this point. You can close the tab. So now you have one table which is imported. Now I will import another table using this add button. This is the second way by which you can import. First way, click here, create table. Second, you have a add button sitting next to Explorer. Click on that and this kind of a pop-up will come. Again, let me import it from a local file. So there are 3 options here. There's local file, Google Cloud Storage. This Google Cloud Storage is not your Google Drive, by the way. I'll show you Google Drive. And third is connections to external data sources. So here you can connect to other databases from where you can, or data sources from where you can set up connections and import data from there. So local file, click on that. The same table will, the same dialog box will come. Select file, browse. Let's say I'm going to import another file called, this time let me import order details. I'm going to say open and data set. If it is not loaded, I will, when you click on it, it is going to show you all the data sets available under your particular project. So we want to import it in classwork and the name of the table is order details. I will again say auto detect, say create table. So it's doing a load job and then it is importing the table here. Now third, I'm going to import a table from Google Drive. So what I have done is some of the data sets I have put it in Google Drive. Okay. Now I'm going to import one particular table today, which I think I want to work with another table today, which is authors. Okay. So in for you to be able to import a Google Drive sheet or a Google sheet within big studio, BigQuery, it has to be present in the form of a Google sheet. So when you upload, let's say when you have uploaded all of your CSVs, it just says .csv. Now you need to open it using a Google sheet first. So double click on this file, open with Google Sheets. Give it a couple of minutes. So this data set is now loaded onto Google Sheets. Okay. Now, what we need to do is, I'll go back to BigQuery. I will click here and say create table. And instead of empty table, I will say drive now. Okay. File format, CS, no, not CSV, I think Google Sheets. And in this, we need to mention the drive URL. So here, click this name, this entire thing first. Okay. Control C, copy it, paste it. Now, when you paste it, select up to here where it says edit. It will always say edit because whenever you open it up with Google Sheets, no, this is an editable page which opens. This is an editable page. Now, we don't want this edit thing. So just backspace it from the URL, remove this slash, and make sure only this much is there. I could have copied it from here, but because of this share button, I was not able to copy up to this point. So I copied the entire thing. There is going to be a edit thing in the URL. Get rid of that part from the URL. Just make sure only this much of the URL is visible. I don't need a sheet range. So sheet range is useful when you only want to import a certain part of the Google Sheet or CSV or whatever. Then you have to give a name to the table. So this is the authors table. So I'm going to call it authors. And here I will set the schema. You can also auto detect, but I'm going to set the schema here manually so that you know how to do it. So I know that this has author ID, name, birth year, and country. Out of that, birth year is a numeric field and the rest are categorical or string fields. So I'm going to say add field. And here I'm going to give it a name, author ID, type string. Next is name. Yeah, third is birth year. Birth year. Now this I want it as a number. So I will click on the drop down here and choose integer. Last is field. Last field is country, which is also a string. So here I'm manually setting the schema. The reason I'm doing this is because sometimes when you're importing files from Google Sheets, the auto detect creates a bit of a problem. So as a practice, if it is working for you properly, then it's okay. But for me, sometimes this auto detect does not work properly when I import files from Google Drive. So that's why it's my general practice that whenever I'm importing data from Google Drive, I manually type in the schema like this. Okay. Then when you're manually typing in the schema, click on advanced options and header rows to skip. So here I will say 1 because the first row in this for me is the header or the column names. So I'm saying header rows to skip 1 and I will say create table. Authors is created. Click on the table. See the fields are correctly imported. And whenever you are importing a data from Google Drive, you will not be able to see the table preview. I don't know why that happens, but it's just how it is. So we'll query this table at a later stage, but for now it has imported it correctly. All right, so now I have imported 3 tables using this button here, add button here, and also we have used a connection with Google Drive. Okay. Whenever you are working, if you want, you will get a set of multiple data sets. Ensure that all of that is imported within your uh, BigQuery Studio so that you can work with them simultaneously. We will be working with multiple data sets together, multiple tables together when we are doing joins and subqueries and those things. So make sure that whenever you are working, import all the data sets in one go. Okay. All right. So now I think this is what this document was covering. This is talking about how do you import different files, loading data into BigQuery, create a table, running. Okay, from here we are going to start running basic queries. But before that, we can go back to our original. Yeah. Now we are going to talk about different commands in SQL. And we are going to code all of this in BigQuery Studio. All right. Give me 1 second. I'll just connect my keyboard. All right. All right. So the first family of commands in SQL is called Data Definition Language, or DDL. So as the name suggests, they are used to define and manage database objects. So they're used to create those elements, alter them, drop them. So basically, manipulate how those objects are going to be in your database. Now, I'm going to use the term database and dataset alternatively here, because in not Google Sheets, in BigQuery, your database is called a data set and your tables are called tables only. Okay. We're going to primarily work with this employees table. But first things first, we have to understand how to write these queries. So the first query that we're going to talk about is a create query. So a create command helps you to create a new table, a database, index, or view. Now, whenever you're working with, let's say, a tool like MySQL, you can actually create a database using the create command. But when you're working with BigQuery Studio, you cannot create a database using this create command. You will have to create it in this way, like we just did. So we went here and we said create dataset, blah, blah, blah. Okay, that's a difference, and just keep that in mind. The syntax is very similar, so it shouldn't be a problem. But we will create a fresh table within our database now using this format. Forget about the primary key for now. This will talk about when we are talking about constraints. But for now, we will create the same code. So how do I start? On your home page, you will have this query button. Click on that and this page will open up where you can start typing your query. So we will say create, and then we'll say table. Then we have to mention the dataset name within which you want to create the table. So we want to do it within classwork. So I will say classwork dot customer. So classwork is my dataset or database name. Customer is my table name. Then I have to give all the field names. The syntax for that is you start with a bracket, and within bracket you write the name of the column and the data type of the column. So let's say it will have a field called customer ID. Let's say its data type is INT64. We will talk about the different data types in the later session. Understand that I am asking BigQuery to create a field called customer ID with the data type as number, and the exact length of it is going to be 64 bits, comma. To create multiple fields, you have to separate them by comma. The next is name. This, I want it to be a string or a text data field, so I will use a data type string, comma, enter. Email, again, email will be a string field because it will have alphanumeric data, and that's it. Close it with a semicolon. Select the query, and then there's a run button over here. Click on that. It's taking some time, and then it says this statement created a new table. See, now it has created a table called customer. Okay. So click on that table, and this is your schema of the table. So customer ID, I created you calling it an integer data type, then name and email as string data types. Okay. You also have the preview button here, but we don't have any rows or any information within this table, so that's why there's no data to display. Okay. So we understand that create command is used to create a new table, database, index, or view. Index or view we'll introduce in later classes. Understand that you can create a new table at this point using a create command. Now, once this is created, if I want to alter the existing database object, then I will use the command alter. Now, alter helps me do three things. Okay. First, it is going to help me add additional columns to my existing tables. So, my current customer table has customer ID, name, and email. Now, I am going to add a new column or a new field to it called phone. Okay, using alter. So I will say alter. I have to say table. Write the full name. So in BigQuery, you will always have to mention the dataset name dot the table name. Otherwise, it will not be able to, it will give you an error. Add column phone string. Now, one thing that you will note is the difference between how these data types are mentioned here and how I am coding them. That's because BigQuery does not understand the data format as varchar. So whenever I wanted to take a string data type, I will have to mention it as a string. These are small changes in terms of syntax of how it works in, how SQL works in BigQuery versus other tools, MySQL, Oracle SQL, and things like that. Those are things which will change when you move from tool to tool. So don't worry about that. Whenever you go through this PDFs, these codes are fully compatible with your MySQL. So these data types or data format, data in formats are exactly how MySQL codes them. But when you if you work with, let's say PostgreSQL or Oracle SQL, then these will again differ slightly. So don't worry about these. And one thing that I want to point out to you is it might so happen that the organization you work with might use a completely different tool for SQL. So you will have to make peace with the fact that these formats keep changing between what you have learned versus what you have to apply. Understand the concept of SQL, that how do you code it? What do the keywords mean? Your keywords meaning your create, alter, drop, insert, what do they do? What can you do with those? That is your core of SQL, and that you should understand. These data formats and informats will keep on changing, so don't worry about it. Once you start coding, it will take you a day or two to understand that on the tool, based on what tool you're working on. So in BigQuery, your varchar or your text data type is denoted using string. Okay. All right. So what I'm telling BigQuery here, I'm saying alter table classwork.customer, add a new column called phone, and the data type for that is string. Let me run it. This statement has altered the table. Now, if I click on customer, in the schema, you will be able to see phone also. Now, alter helps me do two more things. Okay. Alter also helps me drop existing columns in my table and also rename columns in my table. So now I am going to drop this column phone which I have just added. Okay. So alter table classwork.customer drop phone. Okay, so I'm telling it that please drop. If I just say phone, it will give me an error. That means it doesn't understand what is phone. I have to tell it that drop column phone. So see, the syntax in SQL is very, very important. Run it. This statement has altered the table. Now if I go on the table, that field is dropped. The third thing that alter can help me do is rename columns in my table. So I am going to rename, let's say customer ID to cust ID. Okay. So I'm telling, again, I have to mention column here. So I'm telling BigQuery, alter table, blah, 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 rename column name from customer ID to cust ID. Run it. This statement is altered. Go to the table. See, now the name is changed to cust ID. Okay. So we have looked at alter now. So alter helps me modify an existing database. Modify in what way? Add columns, drop columns, rename columns. Okay, three things. Third DDL command is drop table. So now the third thing that I want to do is I want to drop the existing table. So I will say drop table classwork.customer. Run. This statement deleted the table customer. See, now that table doesn't exist anymore. So a drop helps delete the existing database element from that database. So I have dropped the table. But I want to use the table again. So I'm going to just create it again using this code so that it exists for me. I just created the table again. No renaming, nothing. Okay. So now we understand DDL commands. So they are used to define and manage database objects. So we created a table, altered its schema, and then we dropped it. Okay. The second family of commands is called DML commands. Now DML means data manipulation language. Now that is used to manipulate the data which is already stored in database tables. Manipulate in the sense that, sorry, if I want to add new rows of data to a table, I will have to use an insert command, which is a part of my DML family of commands. So insert helps add new rows of data to a table. The syntax for insert is insert into, then you have to mention the name of the table. Now see, one small difference between DML commands and DDL commands. In DDL commands, you always have to mention create table, blah, 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 alter table, blah, 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 drop table, blah, blah, blah. You have to mention the type of the entity every time. But in DML, you don't have to do that. You simply write insert into the table name directly. The reason for that is DDL can help you do create, alter, and drop anything. It can be a table, a database, an index, or a view. These are all different entities within a database. Okay. But a DML will only help you manipulate data within a table. Now, because in a DDL, you can work with different kinds of database entities. So you have to specify what kind of entity are you creating? What kind of entity are you altering? What kind of entity are you dropping? But in DML, because you can only work with tables, you don't have to specify, you don't have to say insert into table customers. That's a difference. Remember that. It's a syntax difference. Okay. Getting back to insert, the syntax is insert into table name. Then in brackets, this is optional. Okay. This part is optional. So here I'm specifying the order of the fields in the way I'm going to feed the values. So I'm saying insert into table name. In brackets, I'm saying field number 1 is going to be customer ID, field number 2 name, and field number 3 is email. And when I specify it in this order, I will have to exactly follow the same order when I feed in these values. Okay. This format you already have. So whenever you're practicing practice this one also. I am going to show you the format where I'm not going to give you this input. Okay. Now, I'm going to talk about DML now. So I'm going to write a comment, DML commands. So the way you write a comment within BigQuery or any SQL tool is you start with a slash, then you have to put in 1 or 2 stars. 1 star also works. I just have this habit of putting in multiple stars. This is the correct format. Okay. So that is a line number 18 is a comment for you. Okay. All right. So insert into. Now I've already again created this table customer. Now I will insert values into it. So I will say classwork dot customer values. This is how the format is. You will always have to say values, and then within brackets I will specify my values. Now I'm not specifying those column names here within bracket. So then in that case, I will have to exactly follow the order in which the columns are saved within my table. So in my table, customer ID is my first column, followed by name, followed by email. So if I'm not specifying the column names order within bracket over here, then in that case, I will have to follow this order to feed in the values. So first is going to be my customer ID. So 1, because my customer ID is a integer or a number format. That's how I've set it. Then name, let's say Jane Doe, and then email ID. So jane.d@gmail.com. Okay. Then I will select this and I will say run. This statement added 1 row to customer. Now if I click on customer and I say preview, it is going to show me that data. Okay, so it has correctly imported or added this row of information using insert. Now I will do a multi-line insert also in so here I'm adding a single row of information. Let's say I want to add 3 rows of information together. So how will I do it? Insert into classwork.customer values. The keywords are not case specific. Okay, you can write it in any case. Then within first every row of information that I want to add will have to be in a separate set of braces or brackets. So 2, let's say the person's name is Marie and her email ID is marie.q@gmail.com. Then I want to add another row of information. So I will say comma, enter, another set of brackets. Within this, I can feed in another name. So let's say the next person is Jane R. And for Jane, maybe there is no email ID that I have. So I will say null. Okay. So here I am adding 2 rows of information. For second row will take 2 Marie and this email ID. And for third row of information, I have the customer ID, the name, but I do not have any email ID. So that's denoted by simply calling it as null. Done. The statement added 2 rows. Let's see if it added it correctly. Click on customer, click on preview. See, it's correctly populating everything. Okay. So now we understand what insert does. Insert helps us add new rows of data to table. We have looked at the format to add a single line of value, single row, as well as multi-row. Okay. Now, second is select. Select is essentially your most important keyword, which you're going to use 90% of time in SQL. So select helps you retrieve data from one or more tables. Today, we are going to look at a single table. When we start working with multiple tables, we'll talk about how do you include them. Okay, so I will show you 3 things. One is with this condition. Okay, first, simple. First, we will talk about what if I want to see all rows of information and all columns. So I will say select star from classwork.customer. Okay. So when I say this, I am telling BigQuery that show me all rows and all columns sitting in this table. So it is showing me all rows and all columns. If I want to see only specific columns, I will have to name them. So let's say select customer ID name from classwork.customer. So here I'm specifying only 2 column names. So in my out, if I run this query, it will only show me customer ID and name. Email ID will not show because I'm specifically asking it to show me only mentioned column names. Okay. Third is it is using a where condition. We will talk about more varied ways of using where, but a where condition essentially puts a filter on the query. So this query tells BigQuery or any of your DBMS where you're working, it's telling it that select these columns from table customer where this condition is satisfied. Okay, let's write it down. So I will copy this same code, paste it here, and I will say where customer ID is equal to 1. Okay. So when I run this code, only this row of information will show up because I am essentially putting a restriction on the query. I'm saying that from the table, only show me those rows where this condition is satisfied. And that's happening only for one row in our case. So we select this query, run it, single row. We will talk about more uses of where, but right now we needed to introduce the concept of how do you filter in your query. Okay. So we understand select and insert. Third is update. Update means you want to modify the existing data sitting in a table. So there's a difference between alter and update. Alter also modifies, update also modifies. alter will change the structure of the database object. Per se, it will change, it will add new columns, delete existing columns, change the name of the columns. But update will only change the values in the columns. Okay. For example, let us copy this code. Let's see if this copy works or not. So I'm going to copy this from here and paste it here. Okay, it works. So I am telling BigQuery that update table, set email ID as this, where my customer ID is this. So I am telling BigQuery that wherever this condition is satisfied within this table, do this activity. So set email as this. Currently, what is the email ID for customer ID 1? If I run this query, it will give me all output, everything for the table. So for customer ID 1, the current email ID is jane.d@gmail.com. I am telling BigQuery that in this table, wherever customer ID is 1, please set the email to this particular email ID. Okay. So if I run this query now, not found. Okay, because it says customers. Change the name, run it. This statement modified one row. Let's see what kind of modification it did. Control C, Control V. I'm going to use the same code now because I want to see what changes it was able to do. So I will use this query. See, now for customer ID 1, the email ID is changed to john.doe@example.com, which is exactly what we asked it to do. Okay. Now, in this update statement, if this where condition did not exist, so if the code simply said this, then it will affect all rows of all rows, because I'm not giving it a condition. So if I don't give it a condition, then SQL understands that do this activity for all rows. So it will take this email ID column and set it to this value for all rows. Okay, if I don't give it a where condition. You can give it a try and see if it works or not. Run it. Update must have a where. Okay, so BigQuery has this check in place. This is an internal check that it does, and it is saying that update must always have a where clause. This error will not come if you do it in MySQL or Oracle SQL. It will let you run that code. But here it does not let you do it. But essentially, if it lets you do it, then it will change the email to this value for all rows. Okay. Now, last DML command is a delete. So delete is removes existing data from a table. Now the counterpart of that in a DDL is a drop statement. A drop command will drop existing table. So the full table will get deleted. A delete command only deletes data or rows from the existing table. So here I am telling it that delete from customers where customer ID is 1. If I copy this, paste it, and set the name correctly. So here I'm telling SQL that delete from table. So delete those rows from table where customer ID is 1. That means that one row where customer ID was 1 will get deleted now. See, it says the statement removed one row. Let's see what kind of removing it did, whether it correctly removed or not. Run the query. See, now it doesn't exist. Here also, if you don't have the where condition, then in that case, it will delete all rows from the existing table. But as far as I know, BigQuery won't let you do it. Like it did not let me update the table without a where condition. Similarly, it won't let me run this delete query without a where condition. But other tools let you do that. Other DBMS will let you run the delete without a where condition. Okay, so we have looked at DDL and DML commands, which is going to be your primary building blocks in SQL as data analysts or any kind of, I mean, in analytics, this is mainly what you use. There is something called DCL and TCL. I will explain those very briefly. TCL is basically transaction control language. Transaction control language we will talk about in greater detail in advanced sessions. There are some examples there. Today I'm just going to introduce you to the concept of both of them. Now DCL, as the name suggests, is I think it's called database control language. So like earlier also I explained to you that when you want to give only certain rights or certain permissions to a certain set of users, you use DCL commands. They help you to control access to data in the database. So either you can grant a permission or you can revoke a permission. This is the format for that. So grant followed by the privilege. So here they have given you an example of only one privilege. There can be 5 or 6 types of privilege. Per se, you can do a select, you can give a select privilege, insert privilege, update privilege, delete privilege, or all privileges. Okay, these are all DML commands which we spoke about earlier, just right now. So select, update, delete, and insert. These four. These are the 4 privileges that you can either grant or revoke on. Then you have to specify which table or which database. This is what you specify here. Followed by keyword 2 and then user. This user is going to be given again based on how that user is specified in your organization. So that changes. This might be like localhost @ username, whatever the user's name is, their ID, or however it is structured. Revoke means if they already have those accesses or those permissions, you take those accesses back. Now, just by looking at this, you understand that this is primarily done by people who are data admins or who control how the database is structured, who gets what rights, what privileges. And strictly speaking, that this does not fall under the purview of analytics. It's more of data management kind of role. Okay, database management manager kind of role. So just understanding the concept is sufficient for you. Also in BigQuery, it doesn't give you grant, select, I mean the select, update, those privileges are not shared. I mean those are not how it is in BigQuery. So what I can do for you is maybe I can give you a small resource. If you are interested, then you can go through it. Otherwise you can ignore it. This much of information to understand is enough for you for the role that you're training for. TCL are used to manage transactions. Transactions is nothing but a set of commands or a set of steps within that you're coding. So right now, if you see, you have written so many codes, right? These are so many lines of code. This is called an individual line of code. A selection of multiple lines of codes is called a transaction. A transaction helps you do a certain activity. Let's say the activity is that I want to create a new table, add these many rows to it, update the information like this. So that's going to be a set of transaction. And what happens is, if you want to save all of those changes that you have done in that transaction, then you use commit. If you want to roll back or undo some of the changes that you have done, Then you use the command called rollback. Save point is within that transaction, if you want to set that, okay, this set of transaction, I want to treat separately from the rest, then you use save point. We will talk about these in greater detail. These are slightly advanced concepts. So just understand that TCL is transaction control language, which helps ensure that any changes that you're doing to your database elements, they reflect after you have done making all of those changes, or you have certain controls to undo those changes, those kind of things. This helps you do. We will look at examples of this at a later class. So, which is why, see here also, they've not given you the codes because these are slightly advanced. Okay. The next thing is data query language. Data query language is a subset of SQL focused specifically on querying data. And the only component of that is a select statement. Because what is a query? A query is when you try to fetch data from your database. What do you use? What command do you use to fetch data from your database? A select command. So your select statement is the core of DQL or data query language and is used to specify columns to be retrieved. So all that you should remember from that is DQL is a family of commands in SQL, and the only command which is there in DQL is your select statement. Okay, so in a way, your DQL is a subset of your DML commands. Okay, now any questions or doubts till this point on in this section? Okay, all right. Now I will. Okay, thank you, Subbalakshmi. Now I will talk about CRUD operations. CRUD operations, as the name suggests, means create, update, read, and delete. That's the expanded version of CRUD operations. Now, what are the commands which are used to do CRUD operations? Those are essentially your DML commands. So create, C, which stands for create, means you want to add new data into database. And for that, the command that we use is insert, like we looked at it. So create operation in SQL is done using insert command. Read, R stands for read. Read means you want to retrieve data from the database. Retrieve data from the database, what command do we use? We use select statement for that. So that's the second DML command we looked at. The third activity in SQL that you do is update, which stands for U in CRUD operations. Update means modifying your existing data in database. So for existing records, if you want to change the values in certain columns, then you use your update statement, which is your third operation in your CRUD operations. And D, which stands for delete, means you want to remove data from the database. And for that, you use your delete command. So these CRUD operations is nothing but the DML family of commands, which we looked at, which is also known as create, read, update, and delete. And the commands for that we looked at in detail when we were looking at the DML family of commands. Okay, this is why I wanted to do CRUD operations in the end. This is so you understand what each of these concepts are. Okay. All right. Now we are going to be we are going to talk about the where clause now in greater detail. So we've already used the where command once when we were working with the select statement, the update, and the delete statement. Now I'm going to use different comparison operators with where clause. We will talk about logical operators and matching patterns tomorrow. to refine the where clause. Today we are going to look at some more examples of where clause. So, let's call this where clause. So we have looked at one where clause where I think for all of the where clauses, we looked at where customer ID is equal to 1. Now I'm going to look at a different table, which is the employee table. If you remember, we imported this employee table. So I'm going to first look at the entire table, select star from class work dot employee. First, let's look at the table. So there are some 299 rows and the table looks like this. There's an employee ID, name, department ID, hire date, city, and salary. Okay. So let's say that I want to filter this table where city takes the value Chicago. Okay. So I will say select star from table name where city equals. Now I know that city is a string field. Okay. If you are not sure of the schema, click on the table once. The schema will open up. So here we can see that that city is a string field. I will go back here. So if it is a string field, the value that I specify has to be within quotes. And if it is within quotes, it is going to be case sensitive. So I have to word it exactly how Chicago appears here. I cannot put all of this in uppercase because Chicago here is in proper case. Run this. See, now you have 66 rows. Here, this is telling me the number of rows which this query is going to give. Okay. Now, what if I want to filter the table for all rows where city is not equal to Chicago? So I'm going to take the same code. I want to filter all rows where city is not equal to Chicago. The comparison operator for that is less than and greater than sign. And then I can run it. See, now it is 233 rows. And you have other cities, Houston and others. Okay. Now, maybe I'll also filter the data for, let's say, where salary is greater than 60,000. So I will say, I will use this entire thing. In the end, in the condition, I will specify where salary is greater than 60,000. So I want to filter out, I want to query those rows of information where my salary exceeds 60,000. I run this and I get 201 rows of output. And if you scroll down, all of your salary is going to be greater than 60K. Okay, so we understand how where works. Logical operators are useful where you want to use multiple conditions. Up to here, we are using a single condition on a single field. If I want to combine them, then I will use logical operators. We'll talk about those tomorrow. The other thing is matching patterns. This also we'll talk about tomorrow. So let's not get into it. Let's talk about order by. We'll do order by and then we'll close for the day. So order by helps you to sort your data or sort your output, because select is a query command. It is going to give you output based on the query. So this order by helps you to sort the output of that query. Understand this difference, that whenever you use a select statement, it is not going to create anything. It is not going to, so in a select statement, if you're putting your order by, it is going to sort the output of that select statement. It won't sort the underlying data. The underlying data is still going to be in that same order in which the data has been imported. Okay. A select clause only outputs a certain snapshot of the data. And if I use order by in that, it is going to sort that output. Okay. So let's say I want to sort this data by hire date. So I will say select star from classwork dot customer employee order by hire date. So hire date earliest to latest. If I don't specify any order, no ascending, descending after the column name, it is by default going to sort it in ascending order. Now, if I want to sort it in descending order, I will say, now I will only have to specify the order of sorting as descending if I want to sort it in descending order. If I don't specify anything after the column name, it will automatically sort it in ascending order. Remember that. I think that applies for all tools. So that's a uniform rule. See, if I use hire date descending in order by, it is sorting it in descending order. So latest followed by earlier dates. What if I want to first sort by city followed by hire date? So two fields. So I will say this order by, first I want to sort it by city, and within that sorting, I want to order sorted by the hire date. So I will say city, comma, hire date. Let me still use ascending order. So for first, it is going to set give me the data sorted in city, and within each of those categories of data, it is going to sort it by hire date. Run it. See, all of your Chicago comes first, and within Chicago, the hire date starts from earliest to latest. This has only 50 rows. If you move on, you will be able to see. Okay. The format for that is like this. So first you have to specify order by, the first column by which you want to sort. For ascending, you might as well not specify the sorting order because by default it will take it as ascending, followed by the next column, then it's order, followed by other columns. Okay. All right. One last is a limit clause. So I'm gonna just also talk about limit. So limit means if I want to limit the output to only certain number of rows. Right now the result shows 50 observations. If I want to only see 10 observations, then I will use the limit clause. So select star from classwork dot employee limit 10. So I am telling SQL that query this table and give me the first 10 rows from the table. See, it shows you only 10 rows. It still says result per page is 50 because that is by default. But see, it will only show you 10 rows of data because I say limit 10. Okay, so this is if you want to, it's like the when in Python when you specify head followed by table name, so you get only 5 or 10 rows of observation. Okay, so we will stop at this point today. Please set up your BigQuery Studio and import all the tables which have been provided to you. I think there are some 8-10 tables. Please import that and have that set up. One small word of caution, there is one table called customer as well, and we also have one table called customer. So maybe whenever you're creating this table, if you're creating it as I have created, maybe rename this to customers and not customer, okay? So that there's no problems there. Let me just check. You have a customers table. Okay, so then that's okay. You have a customer's name CSV file that you will have to import. So then you can follow with the code as I have given. So please set up your GCP account, uh, get this this BigQuery Studio set up, and start working with the class, because this is a pretty simple. I mean, today's session was pretty simple. We only covered the basics of basics, but starting from the next class, we're going to start building on that, and it's going to get a little more complex. So follow with the class so that you are able to better cope with everything. And once you're done coding everything, save it. Save query. It's going to ask you for a name. So I will call it classwork. And see, it specifies a different region now. And don't bother with it. This is just from which server's region is going to hit to save it. So here, see, it will get saved. Under queries in your project, it is going to get saved. Okay. And this is all of your tables. That's about it. When you open up your GCP again, your your BigQuery Studio, all of this is going to be sitting there because it's saved automatically. Just make sure that you save your query, otherwise your query will get deleted when you close this interface. All right, thank you so much, guys. Good session. I hope it was useful for you. Let me know if there are any doubts or comments or concerns. Okay, thank you. Good night. I'll speak to you on Thursday then.